I'll go ahead and start recording. So you guys just call out a number, whichever one you want me to get started with.
Could you try 44?
Yes. Okay, number 44. So this one kind of looks similar to the ones that we had on the review, I guess that we did in class yesterday, where we have four, let me make this smaller, 4 different bases. And so I'm going to circle all 4 of those just to make it easier for myself. And if you look at all 4 of them, just understanding that you can take all of those and bring those down to 3, or they all have a base of 3 in common. So I'm going to write 3 to the first power. 9 I'm going to represent as 3 squared. I'm going to go ahead and multiply that times 2x. So I'm going to call this 4x. Then on the right-hand side, 27 is 3 to the third power. And then the last one is already 3, so the x plus 1. Then the only way that you can set the exponents equal to each other on both sides is if you just have 1 3 on the left and 1 3 on the right. So to combine these on either side, you're going to add them together. So I'm going to take 1 plus 4x. And on the right, I'm going to take 3 plus x plus 1, which would end up being 4 plus x if I combine my like terms. So now I'm at the point where I can set the exponents equal to each other. So I can say 1 plus 4x equals 4 plus x. And then if I solve, I get 3x equals 3, so x equals 1. Okay, what's next?
Number 42.
42. Okay, so this one's like the challenge problem, and I can either confirm or deny that there might be one like this on the test. So we do need to know how to do it. So what you want to do first is all 3 of these terms, we're going to pull out a greatest common factor, which in this case would be e to the x natural log of x. And then from there, you'll write whatever you have left over. So 6x squared minus 19x minus 36 equals 0. Then from there, I'm going to factor what I have in parentheses. Go ahead and bring this down. And I have no idea what that would be. Maybe 9 and 4. 8, 27. Yeah, that works. Like that. So then from there, you're going to take each component and set it equal to 0. So I have e to the x equals 0, which that can never happen. You can't think of any number that I would put in for x that would make that a true statement. The second one, I'm going to set equal to 0, the natural log of x. To solve something like this, I would change it to exponential form. So e to the 0 equals x, which would end up being x equals 1. The next one would be x equals 9 over 2, and x equals negative 4 over 3. And then since this is a logarithmic function, I would need to plug back into the natural logs, which would mean that this negative 4/3 would not work because it would end up being a negative inside a log. So my 2 answers would be 1 and 9 over 2. Now something you might see, because the 2 examples that we've seen have been just natural log of x, pulling that out, I'm just gonna maybe make a little note because it could potentially show up on the test. let's say, for instance, I pulled out natural log of 4x. So if it weren't just x, but it were a number inside. So all of these were 4x instead. So if I'm setting natural log of 4x equal to 0, I'm going to treat it the same way. Let's say e to the 0 equals 4x. This would cancel to become 1 equals 4x. So x would be 1/4. So I would write that down and maybe look it over before. That would be an example if it were something else inside the natural log. Okay, what's next?
So besides that, what else do you have to like plug back in and check your answer?
So anything that is a log equation or a natural log, you'd have to plug back in. So if I'm just skimming like these solving problems, something like 39 and 40, remember I told you guys we're not going to waste our time checking with those. So you wouldn't need to check 39 or 40 or 41. 42, you would need to check because you have a natural log. You would need to check 43 or 44 or 45 or 46 or 47. You would want to check 48 and 49 and 50 and 51 and 52. So what they all have in common is that they have a natural log or they have a log as the equation, but ones that are just exponential, that have e's or just numbers, you don't need to check those.
Miss McKinley,
Mhm.
Can you explain the difference between the two equations in 8.7?
In 8.7. Oh, we aren't testing over 8.7.
Oh, okay. Thank you.
So yeah, don't do, I said this in class, I think you're absent, but don't do anything on the last page
Okay.
for right now. We're gonna take a quiz over it next week, but the calculator stuff will not be on the test.
Do we have to know how to do the 53?
Not for the test. I'm just gonna go ahead and put that on the quiz because I just figured it would be silly to make like one question be a calculator question. So I'm just gonna go ahead and bump it to the quiz.
So no calculator at all?
No. All non-calculator.
Would you go over number 47?
Uh-huh.
Thank you.
Okay, 47. So a question like this is an exponential, but you unfortunately cannot get them to be the same base. So in that case, you're going to have to take the log of both sides. What I told you guys in class is basically choose whichever base had the exponent attached to it that had the least number of terms. So like this has 2 and this has 2. Since they both have the same terms in the exponent, it would just be something either one. Like, so I could take log base 5 or I could take log base 3. So I'm just gonna go ahead and move forward with log base 5 because it's on the left side. I don't know, just because I want to. So if I chose log base 5, the long way would be this 2x plus 1 would jump out front, and the log base 5 of 5 would cancel. So I would just have 2x plus 1 on the left. Then on the right side, I would have x minus 2 in parentheses, log base 5 of 3. So at that point, I want to get my x's by itself, like everything with an x I want on one side, and then everything that's just a number or a log I want on the other side. But first, since this is in parentheses, I'm going to need to distribute the log base 5 of 3 to both the x and the -2. So I'm going to rewrite this as, let's go ahead and put the log first. Log base 5 of 3x minus 2 log base 5 of 3. At this point, now I'm going to use the same 3 steps that I had you guys write down that you do every single time you have multiple x's in an equation and you're just trying to solve for one. So this term has an x and this term has an x. So I'm just going to box those. I want those to be on the same side. So I'm going to move the log base 5 of 3x to the left, and then I'm going to move the 1 over to the right. So I'm going to rewrite this as 2x minus log base 5 of 3x equals -1 minus 2 log base 5 of 3. And it doesn't matter which order you put them in. You could put the 2 log base 5 of 3 first, -1. It doesn't matter. Then at that point, I have an x here. I have an x here. So I'm going to factor that x out. And I'm going to rewrite this as whatever I have left over. So I've taken the x out of both of these, and I'm left with 2 minus log base 5 of 3 equals -1 minus 2 log base 5 of 3. Then I'm going to divide all the ugly stuff that's in parentheses. Move that to the other side. And then I'm done. So I want you to stop. Do not keep trying to simplify. A lot of you are going to want to try and do that, but don't do it. That'd be what we call puppy killers. So leave it be and stop there. And I know it's a super ugly answer, but just trust that you did it the right way if you follow these 3 steps. So step number 1, getting the x's on the same side. Step number 2, factoring out the x. And step number 3 is dividing by the stuff in parentheses.
Thank you.
Okay, what's next?
Could you do 45?
Okay, 45 is similar to one like 44, but I now have one that's in a fraction. So first step is I'm going to circle my bases. Something that I anticipate happening, or I think I just saw some people doing this on in class yesterday, but I saw several people that wanted to like cross this out and say 1/4. But the reason why you can't do that is think about PEMDAS. 2/8 is considered division, but 5x is considered an exponent. So in PEMDAS, the exponent comes before division. And so I can't divide 2 divided by 8 because I have this exponent right here. And since there's an x in it, and I don't know what x equals, I can't actually evaluate the exponent. So that means I definitely can't do division. So just remember that. So if I have a question like this, what I want you to do is circle all of the bases that you see. So I have a 4, a 2, and an 8. And I want to represent that as having a common base, which in this case would be 2. So I'm going to represent each one of them as 2 to a certain power. And this is x to the x. So I'm going to go ahead and cross that out and put x squared because it's a power to a power. So on the left, if I'm going to write it as 2, then it would be 2 to the 2x squared. And then on the right side, this stays as is. So I'm going to say 2 to the 5x. And then since this is on the bottom, 8 is considered 2 to the 3rd power. But since it's on the denominator, I'm going to say 2 to the negative 3. You could also think about this as if you wanted to split this up into top and bottom, you could cross this out and say times 1/8. Because essentially that's what you're doing, is multiplying it by 1/8. And so remember from the last example, you cannot, you can't set the exponents equal to each other until you combine these two to be 1. So I need to combine the exponents by adding them together. So that would end up being 5x minus 3. So I'm going to come over here and say 2 to the 2x squared equals 2 to the 5x minus 3. Now I can set these equal to each other. So I can say 2x squared equals 5x minus 3. Then I can factor and solve. That's not right. That's also not right. I guess it would switch these 1 and 3. There we go. So you would get x equals 3/2 and 1. Since it's not a log function, I don't need to plug it back in. So both of them would be correct.
And when you plug back into a log, you just have to make sure that it's not negative going into the log.
Right. So in most cases, like, so in 48, I would just need to plug back into, like, I would need to see if 2x plus 1 ends up being a positive or a negative. Here I would plug in here and here. And if when you plug it back in, it becomes a negative number, then you need to cross that out because it's not a solution.
Okay, thank you.
Can you go over number 48?
So number 48, let's see, I could do a couple things. There's not necessarily one way that you have to start this problem. One way would be moving this back up and saying this is a third. Or another way is just dividing both sides by 3. Either way you do this problem, you're going to end up with the same answer. So I'll show you both ways and then you can choose which one you prefer. So if I'm going to start with dividing both sides by 3. So you end up getting log base 8 2x plus 1 equals 1/3. I've isolated the log, so my next step is to convert it to exponential form, which would end up being 8 to the 1/3 equals 2x plus 1. 8 to the 1/3 would be like taking the cube root of it, so that would end up being 2. Then I subtract the 1, and I get 1/2. If I plug that back in to 2x plus 1, I would get 2 times 1/2 plus 1, which would end up being 1 plus 1, which would be a positive number. So this one works. If I were to do it the other way, so if I didn't divide by 3, but I moved that 3 to the exponent, then you would end up essentially doing the same thing. So if I convert this to exponential form, it'd be 8 to the 1st power equals 2x plus 1 cubed. Well, I have to get rid of that cube root. So I cube root both sides, or I raise both sides to the 1/3, the reciprocal. So I'm doing the same thing both ways. Just ends up being whatever your preference is. Okay, what's next?
Can you do number 39?
Okay, 39. So my first step is to get the square root by itself. So I need to subtract 5 to the other side. To get rid of the square root, I square both sides. On the left side, the square root just goes away. On the right side, I have to FOIL it. So it becomes x squared minus 10x plus 25. Then I want to get everything to one side to set it equal to 0. So I can factor. So it would be 2x squared minus 15x plus 25 equals 0 when I move these two things over. And then from there, I'll factor. And you get 5/2 and 5 for your answers.
On number 43, it said that x equals 1 is one of the answers, and I got the 9/4. I just don't know where the 1 came from.
On 43.
Yes, ma'am.
Okay, so I would say this is 7 to the 2x minus 4. And this would be 7 to the 1/2. And then I would set these equal to each other. So I would say 2x minus 4 equals 1/2. I'm gonna double everything so I can get rid of the fraction. So 4x minus 8 equals 1. Don't know.
Maybe I looked at it wrong. Here, I'll look.
The 1 is for the problem below it.
Oh, got it. Okay, thank you.
Yeah, it's number 44, the answer is 1, and then also in number 42, one of the answers is 1. So maybe that's why. But yeah, you should just get 9/4 for 43.
Can you do number 51?
Yes. Oh, 51. I love this problem. Okay. So when you have like a log inside a log, we haven't actually done one of these before, but I think you can probably use your knowledge of logarithms to help solve it. So let's pretend like the stuff on the inside is just like a big X. Like it's just a number, it's just something inside it's inside the outer logarithm. So if I were to convert to exponential form, because right now my log is isolated, so the next step is to convert to exponential form, then I would take 27 to the 1/3 equals all this stuff that's on the inside, which is log base 2 of 2x plus 1/7. So I haven't done anything with the stuff on the inside yet. I've simply just moved it, switched places, and the 27 came up. So at this point, I can actually evaluate what 27 to the 1/3 is by taking the cube root of 27. So that turns into 3. So I'm gonna say, I'm just gonna come over here and say that this equals 3. I don't know why I like my number being on the right. It's just like a weird OCD thing, I guess. So now I am gonna do the same process all over again. So now I'm gonna convert it to exponential one more time. It's like working from the outside to the inside, kind of. So if I convert it again one more time, I'm gonna say that 2 to the third equals 2x plus 1 over 7. And then if I evaluate that, 2 to the third is 8. And then now I can solve for x. So if I multiply 7 times 8 is 56. Subtract the 1, divide by 2. So my final answer is 55 over 2.
Can you do number 52 as well?
So in this same kind of process that we used for 51, we're going to do the same thing for 52. So imagine all the stuff on the inside of the outer natural log is just x. It's just something. We're not going to do anything with it at this moment. So if I convert the outside to exponential form, this natural log has a base of e, so I'm going to say e to the 0 equals ln of x. All this stuff moved, switched places, the e came up. Change this, e to the 0 is equal to 1. Now I'm going to convert it one more time. So you could either look at this and just know that like whenever this number and this base are equal to each other, that's going to equal 1. But if you don't just automatically look at this and say, oh, the answer is e, then you could convert it to exponential and solve it that way. So if I do this one more time, e to the first power equals x. So x equals e. And that would be my final answer. So with like 51 and 52, think about working from the outside to the inside. But you're going to be converting to exponential twice, essentially. You're going to do it once on the outside, you'll evaluate, then you'll do it again for the stuff on the inside.
Ms. McKinley,
Yes.
for questions like 51, 52, 44, 45, 47, like how many of those would be on the test tomorrow?
There'll probably be like 1 or 2 of each type. Like there would be like one that's similar to 51 or 52.
Uh-huh.
One that's similar to like 44 or 45. One that's similar to like 42. I would say like if you can do 41 through, well, 39 through 52 confidently, then you should be able to do everything that's the solving component of the test.
Okay, sounds good. Thank you.
Are there any more that you guys want to go through?
Wait, I have a random question.
Uh-huh.
So like when you have like x equals ln like 10 minus 1, does that ln 10 need to be in parentheses?
No, it doesn't have to be.
Okay. And then with you had like 2x e to the third. Does it matter if it's 2x e to the third or 2e x to the third? Does that matter?
No, it doesn't matter.
Okay, good. Thank you.
Also, if we're good on this review, are we good on the test tomorrow?
You know I don't answer that question.
I was
I
just
don't like
thinking,
answering that question. I think that this review is helpful, but I can't say like you're gonna be 100% golden if you know how to do this review. There's gonna be other stuff on there,
Okay.
but I would say focus on this review.
Thank you.
Will you do number 49?
Yes. Number 49. So this one is an example where you'll need to condense the logs or the natural logs and then convert to exponential. So with this, since it's a minus, I would say that it is natural log x minus 5 over 2x plus 1 equals 3. Then these are the best kind because then you have fractions. So then from here, I'll convert to exponential form, which would be e to the third equals x minus 5 over 2x plus 1. So this and this have switched places. The e has come up. At this point, this is another one. If I haven't like hit you on top of the head enough times to tell you that you're going to have to do this several times on the test, I'm telling you now, you're going to have several that are like this, where you have multiple x's, but you're trying to solve for one of them. That's why I put these kind of questions on the benchmark all the time. So if we run into something like this, you cannot just cross the x's out. If I see people do that tomorrow, I'm going to be upset. So I need to cross multiply first. That's going to be my easiest plan of action. So let's go ahead and put this over 1 and cross multiply. So we have x minus 5 equals 2e to the third x plus e to the third. I always like to keep checking in and knowing where my x's are here and here. So I have 2 of them. I want to get it to 1, so I'm going to have to factor it out. So my first step is move everything to one side, all of my x's on one side, all of my numbers on the other. So then it would become x minus 2e to the third x equals 5 plus e to the third. So this came over here, this came over here. Second step, factor out the x. I have one here, I have one here. If I factor it out, I write what I have left over. So if I've taken it out of the first term, I need to put a 1 there as a placeholder. I can't just say like minus 2e to the third. I need a 1 there for a placeholder. Minus 2e to the third. So imagine if I were to FOIL this back out, I would get back to where I started. That's a good way to check your answer. Equals 5 plus e to the third. Divide by the stuff in parentheses. And then that is my final answer. For a question like this, where you get like a really funky answer, I think I mentioned like you need to check your answers all the time for natural logs or for logs. But if you get something really funky like this, then that you just leave it be. Don't try plugging in something funky. I want you to plug in if you just get a number for an answer. Anything else?
Would you go over like 39, I mean 29 and 30?
Okay, 29 and 30, you're graphing logarithmic functions. So the parent function is at 1, 0, and it looks like this. It's for both of them. So it doesn't hurt to draw the parent function. From there, you're going to look at what the transformations are. So this is going to be right 1 up 2. So my new function would have point right here. And my asymptote has shifted over to where it would be at x equals 1. You can also set whatever's in parentheses equal to 0, and that's going to tell you your asymptote too. My range would be from 1 to infinity, or I'm sorry, not my range. My domain would be from 1 to infinity, and my range would be all real numbers. Range will be all real numbers for all log functions. For exponential, it's the domain that's all real. For number 30, if the x is negative, that means that it flips the y-axis. So if you get your graphs tomorrow, you can label this as x and this is y. So if I flip the y-axis, that means I'm now going to be over here. And then from there, I'm going to go down 2. So it now points this way. My asymptote is still at 0 because I didn't shift left or right any. And if you set this equal to 0, you would still get 0. And then my domain would be negative infinity to 0. So just remember to keep straight which one flips the y and which one flips the x. So if it's on the outside, that's going to be the x-axis. If it's on the inside, that's the y-axis. Do you have any more questions? Okay, so the answer key is on here or on Canvas, so you can always go back and look at that. It has my work shown as well. There's also a blank copy if you maybe want to go through and redo this review. There are also there's the extra exponential and logs solving review. It has the answer key up on Canvas as well as a blank copy if you want to print that out. I think there might be a couple of extra things on Canvas if you want to look for that. And don't forget, I know we did all this 8.1 through 8.4 before, but don't forget about that stuff either. I think it probably will come easier to you now that you've been tested over it, but still don't forget about that kind of stuff. And I'll be at school tomorrow at 7:15. So if you guys want to come in early, but we do start school at 7:45 tomorrow. So if you guys have any more questions, let me know. And don't forget that test corrections are tomorrow as well. So review needs to be turned in on Canvas and then bring your test corrections to class. So if you guys have any last minute things, let me know. I'll be by my email for a little bit longer, but if not, then I'll see you guys tomorrow.
Thank you.
Thank you guys.
Thank
See y'all later.
Thank you.